Hello everyone. In this video, we will see how to predict the number of clusters. So we have a data set that is iris data set, and on this data set we have to apply some techniques and some machine learning algorithm to predict the optimum number of clusters, and then we will present this data or this data set in a visual way, in a visual or the graphical manner. We will plot some graphs, we will plot some charts, so that we will see the beautiful presentation on this data. So before moving forward, I want to tell you that this is a Kaggle platform. This is a Kaggle platform, Kaggle kernel, where we can run all the data science and machine learning code online, right? So I'm not going to show you the entire notebook or the entire Python code for this problem. I'm just explain you, or I'm just tell you the steps I have followed via the table of content. So one by one we will see what step and the procedure we followed here. So it's a very beginner level task, and we are going to use the unsupervised machine learning algorithm to predict the optimal number of clusters. So guys, my name is Sunil Singh and I am the data science and business analytics intern in the Spark Foundation. So let's see what we have here in the table of content. So guys, we have some data, iris data set. In this notebook, this is a Jupyter notebook available on a Kaggle platform. If you want to see this entire notebook or the entire Python code to check how to optimize the number of clusters or how to use the machine learning algorithm on a particular data set, or you want to see the Python code, or you want to see the entire notebook, the link of this notebook is available in the description. So you have to click on that link and check the entire notebook available on the kernel, right? So first we have to import the necessary libraries. The necessity of library we have by over the period of time, when we got some experience, we came to know that what library we want, what library is useful for our project, for our problem. So in a very first step, we have to import some libraries, basic libraries, that is NumPy library, the pandas library, SPD, the matplotlib library, cbond library, and some special library for clustering, for matrix generation, for splitting the data. After importing libraries, we have to import the data from the data source. So in the table of content, the second step is read data from the source. So this is the code available in this notebook. I have applied to import and read the data from the source. And after reading the data from the source, we have to deploy, we have to analyze the data we have got, and this step is particularly known as the exploratory data analysis, exploratory iris data analysis. Here we have to check the rows and columns via head Python command. Then we will describe the entire data. This description is a descriptive analysis or the descriptive data exploration, where we are using the numeric variables. We have to check some mathematical property of the data, especially the mean of the variable, the standard deviation of the variable, the minimum value of the variable, or the minimum value of the data, or we can see that we can check the 5-point summary of the data, which include the 25% the first quartile, the second median, the third quartile, and the maximum value. As you know that we use the term box plot, and using the box plot we can check the 25% that is first quartile, and the median 50% that is second quartile, and the third quartile value, and then we can figure out the interquartile range, and so many things. After this, within the exploratory data analysis, we will check the information about the data, where we can see that we have 150 entries in 6 columns, and column has not null values, 150 non-null values, and the data type of the column. So moving forward, we can check the shape of the data. Here we can see that in a result we have 150 rows and 6 columns in our data. When the data is in tabular form, there is no null values. We can see the sum of null values via variables, and after that we are going to move forward for the data presentation and finding the number of clusters. So in this step we have to follow some procedure, some code. As we can see that in our data we have a categorical variable. So for that categorical variable we import the label encoder, and using this label encoder we encode the categorical value in some code, in some numeric value. So here we have the column name is species, right? So the variable species is transformed into the numeric value. So we can see that this is the column, species column, and we transform the categorical variable into the numerical variable. So in the next step we have some EDA, exploratory data analysis and data visualization, where we can apply some correlation code using the Python for checking the correlation between the variable, and after that we display the correlation of the variable, correlation of the data in a form of heat map. Then we display a histogram of the entire data. After that on this data we apply a Python code to display the pair plot. So these are some visual presentation, or the EDA, that means the exploratory data analysis using the visualization. So let us moving forward toward our important task, or the primary task, and that is to predict the optimum number of clusters. So here in this notebook I applied 2 techniques to predict the number of clusters, to predict the optimum number of clusters. So these 2 techniques are, the first one is hierarchical clustering to determine the optimal number of clusters, and second one is the optimal value of k clusters in k-means clustering. So first technique is hierarchical clustering, and second technique is k-means clustering. So via these 2 techniques I predicted the optimal number of clusters. So here in this first technique, that is hierarchical clustering, to determine the optimal number of clusters, we have to plot a dendrogram. So in hierarchical clustering we have to plot a dendrogram, and using this dendrogram, this is the entire code for the hierarchical clustering technique. Second method for determine the optimal value of k by using the k-means clustering. So for this k-mean clustering, we will use the elbow method. So this is the entire code I have used to figure out the elbow to determine the optimal number of clusters. So this is the graphical, the elbow method. We figure out the value of k, that is the number of clusters. Now moving forward, we create a model using k-means clustering to verify the number of clusters we find out. So we deploy or create the model, the k-means clustering model. Here we put on the value of k, that means 3 clusters we have. Recently we figure out these clusters and fit the entire data set within the k-means clustering, and after that we predict the cluster values. In the earlier method where we use the hierarchical clustering method, in that method also we came to know that the entire data set have the 3 clusters, and in the second method, determining the optimal value of k by using the k-means clustering, here also we came to know that the value of k is 3. So we have 3 clusters in the given data set. This is a symmetry we got from the 2 procedures, 2 methods. So there is no need to verify because using 2 techniques we got the same result, but still we verify this data by putting the value of k in the machine learning model, that is k-means clustering, and here we got the 3 cluster values, 1, and we can see there is 0 also and 2 also. These 3 unique values we have. So it represents that the entire data set is divided into or the classified into 3 clusters. Now we present the data using the k-means clustering method. So here we will use the cluster data. Here we use the cluster data, the data we used in the k-means clustering. You can see here in the cluster variable we copy the entire data we used for the k-means clustering machine learning model. And data, or by using this cluster data, we present some beautiful presentation by using some plots. So this is the scatter plot using the cluster data. Now for the comparison, we also use the initial data, that is iris data. So you can compare that this graph and this graph is symmetrical. There is no difference. The difference is here we have species. As the category in the initial data, and the cluster data have the predicted value. The predicted value 0, 1 and 2, which is identical to the species, right? And again we plot some scatter plot for the comparison, and we also plot a pair plot for the entire cluster data, the data we got from the k-means clustering machine learning model as a prediction, right? So this is the entire notebook. You can see this entire notebook. You can check the code, you can check the comparison, you can check the graphs by clicking the link given in the description box. So at the end we have some conclusion. The conclusion said that by using the hierarchical clustering to determine the optimal number of clusters, and by using the elbow method to determine the optimal number of k clusters in k-means clustering, I'm able to determine number of clusters. That means the value of k is equal to 3. We have 3 clusters in this data, in this iris data.